We're given a graph of pressure versus volume, and then we're asked to find out how much work is done. And so what we want to do is find the area between the line and that horizontal axis. And the area between the line and the horizontal axis, or the area under the curve, is equal to the work. Now this is not a nice geometric shape, so how do we actually find the work done? How do we find that area? We're going to split into two sections, triangle on top, rectangle on bottom. So first we'll find the area of that triangle, and then we'll find the area of the rectangle below, and add them together. Well, the area of a triangle, we'll call that our first section, is going to be 1/2 the base times the height. So our base is going to be from 5 to 8, which is 3 cubic centimeters. And the height we see is from 100,000 to 150,000. So the height is actually 50,000 pascals. Now our units are in the correct value, so we're in cubic meters for the volume and pascals for the pressure. So we get 75,000, and our units would be joules for the area. To find the area of the second section, the rectangle, area is length times width. The length is again from 5 to 8, or 3 cubic meters. And our height, or width I should say, our width is 0 to 100,000, or 100,000 pascals. Again, we're in the proper units, so we get 300,000, and our units, after we multiply it, is joules. Now to get the total work, we simply add those two values together, 75,000 joules plus 300,000 joules, and we get 375,000 joules. Our arrow shows that our line moves to the right, our volume increases, and therefore it is positive work, and that's what our answer is. But what happens now? What happens if we have multiple sections? Let's say we have 3 points. We'll call this point A, point B, and point C. And so we go into circular motion, and we want to know the total work that is done. How do we solve that? Well, again, the work is equal to the area. And so first, we'll find the work done from point A to point B. And so again, it's the area of this triangle on top, which is 1/2 base times height, plus the area of the rectangle down below. It is the total area of this section here. Now we've just solved that. It is the same problem. I'll write out the values. The base was again 3 cubic meters. Height was 50,000 pascals for this triangle on top. The length of this rectangle down below was 3 cubic meters, and the width was 100,000 pascals. And so we get 375,000 joules. Now the line goes to the right, our volume changes were positive, and so we get a positive amount of work from A to B. The work from B to C is actually going to be 0. This is an isochoric or isovolumetric process, and so there is no area. You can't find the area of a line that goes straight down. The very last section, the work done from C to A, well, that's just this rectangle down here, which is length times width. But in this case, the line goes to the left. The volume actually decreases. This was 8 cubic meters, by the way. The volume actually decreases. And so our length is negative 3 cubic meters, and our width is again 100,000 pascals. And so the work done from C to A is negative 300,000 joules. Now we want to find the total. And so to get the total work done, we just add up all of our values that we have calculated. So a positive 375,000 joules plus 0 joules plus negative 300,000 joules. And we get the total work done to be a positive 75,000 joules. So if our graph has that the direction is clockwise, we're going to get positive work done. If we're to be the other direction and it were to go counterclockwise, we'd actually have negative work done. In this case, we have clockwise direction, and so therefore we have positive work.